Good day, everybody. How are you all doing? Today it's a gloomy day outside. Although it's third week of May, we did not see any sun today, and it's been raining on and off today. Okay, so let me start with a joke about a statistician. Why did a statistician always carry a box knife or box cutter? Because he always wanted to find the mean. Why did the statistician go broke? Because he spent his money on the meanest of things. Kidding aside, let's go and start where we left last time. In a recent survey of 655 adults, it was observed that the amount spent on lunch was normally distributed with a mean of $44.60 and a standard deviation of $2.81. Between what two values will approximately 95% of the amounts be? Now, if you remember in the last video, I talked about the empirical rule, which is the observed rule for bell-shaped distribution, which is basically a normal distribution. Now, the empirical rule means an observed rule, which was observed only after observing many countless numbers of bell-shaped probability distribution. So, let's draw the probability distribution of the money spent on lunch, amount spent on lunch. So this is bell-shaped. My drawing is not all that great, but maybe I can erase it and redo it again. This looks like this. Let's draw it like this. Okay, this is a bell-shaped distribution. The center, where the peak is the highest, is, so you have this value where the peak is the highest. Okay, you have money spent on lunch on the horizontal axis, money spent on lunch on the horizontal axis, and you have probability on the vertical axis. So this is the probability density function of the lunch money. Okay, so this is, you can call, probability distribution of amount distribution of the money spent on lunch. Money spent on the lunch, on lunch. Now, they already gave us the information that the mean is 44.60. So this is where the mean is. It's 44.60. And sigma is given the standard deviation. That is an average variation from the mean. The standard deviation is 2.81. This Greek symbol is sigma or small s, standard deviation. This symbol is small m in Greek language, mu, center of the distribution. So now this is a bell-shaped rule. So apply, let me erase this. Apply empirical rule for bell-shaped for normal distribution. Now, if you have stayed with me so far, please do not quit. Please watch till the end, where I will explain how all this is applied. And if you like this video, please give me a thumbs up. If you like this video, share with your friends, and please subscribe to my channel. That really motivates me because I spend a lot of time on developing these problems and solving it all for you. Let me know whether you understand my explanation. Please put something on the comment if you do not like my video. If you like my video, give me a thumbs up. So let me change now the color of my ink, and let's create some space. So the empirical rule, again, empirical rule is the observed rule, states that 95% of the population will fall within 2 standard deviation from the mean. Standard deviation from the mean. Within 2 standard deviation from the mean means you take the standard deviation and multiply by 2 standard deviations of the mean. So let's do that. What I exactly said, my sigma is 2.81. Thus 2 sigma is equal to 2 times 2.81, which is equal to 5.62. Okay. So within 2. So remember the numbers from the mean on the horizontal axis. Those are the population, the money spent on lunch. Okay. Those will increase from the mean on the right and decrease from the mean on the left. So if I do mu plus 2 sigma, remember this number is greater than the mean because I'm adding 2 sigma to it. It is 44.60 plus 5.62, which is equal to 212, 50.22. Now I will find the limit on the left-hand side, the boundary for mu minus 2 sigma. That number is smaller than the mu, so it will be on the left of the mean on the horizontal axis. So let's do that calculation. Mu minus 2 sigma is 44.60 minus 5.62, which is equal to 8,796 is 38.98. So if I may look at this point, one is 50.22. So let me go back. No, I can go back here to this color. So this is 50.22 on the horizontal axis, and the other point is 38.98, same distance away from the mean on the left of the mean. Because that number is less than the mean, hence it is on the left of the mean by the same amount. And that was 38.98. So this is 38.98, this particular point. Now we will draw 2 vertical lines, one over here and one over here approximately. Of course, my drawing is not the greatest, but you get the idea. I draw 2 vertical lines from the horizontal axis at those 2 values and extend it up to the bell-shaped distribution. And according to the empirical rule, 95% of the population will fall between 38.98 and 50.22. That means the area between under the normal curve between 38.98 and 50.22 is 95%. So the answer to the question, okay, the question, remember, was between what two values will approximately 95% of the amounts be? So the answer to the question is answer 95% of the amounts will be between 38.98 and 50.22 and 50.22. I will stop here today. I will summarize what I did before I go. So basically, they said the money spent on lunch is normally distributed with a mean of 44.60, standard deviation is 2.81. Normally distributed means a bell-shaped curve with the peak at the center where the relative frequency or probability is highest. This is the bell-shaped curve. This is the probability distribution of the money spent on lunch. We are required to find out between which two values will 95% of the population. So we use empirical rule, multiply 2 times standard deviation, $5.62. We move on the right, increase from the mean by mu plus 2 sigma to 50.222 standard deviation. On the left, we decrease 50 minus 2 sigma is 38.98. So between 38.98 and 50.22 is where 95% of the amounts will fall. I'll stop here today. Any question, do not hesitate to shoot me a question or write me a comment, or please give me thumbs up if you like this video. And please share this video with your friends. You and your friends, please subscribe to my channel. Please let me help me to grow my channel. I appreciate that. And please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. I understand your time is important and that you are here. I appreciate that. Okay. Please do not forget to watch me tomorrow when I'll be back with another interesting video. Thanks for watching. Take care. Have a nice day.